As students are taught high school physics, there are some important introductions that are given out. First, of course, physics as a subject is defined, that is, the interaction of energy and matter. Next, students are taught about fundamental physical quantities and their SI units. SI units are nothing but the most basic units by the virtue of which we denote measurements. Here are the 7 fundamental physical quantities. The first is length, which is measured in meters. The second, time, which is measured in seconds. The third is mass, measured in kilograms. Following that is temperature, which is measured in Kelvin. Fifth, we have electrical current, which is measured in ampere. Sixth, we have luminous intensity, which is measured in candela. And seventh and finally, we have the amount of a substance, which is measured in moles. Now that we have this set, let us focus on the second fundamental physical quantity on this list, time. Time is one of the most important aspects of our lives. Whether it is something as simple as someone's daily routine, to more important phenomena like the duration of an earthquake, which has the potential to harm the lives of millions, or the duration of a star birth or a supernova for scientific research purposes. Time is also the most important physical quantity. One could say it is the basis of all other physical quantities known to us. Don't believe me? Well, let's look at a few basic quantities known to us and see how their roots are seeded in time. First, let's take distance. All of us know that the base unit of distance is 1 meter. The definition of 1 meter, interestingly, is based on time. 1 meter is the distance traveled by light in a vacuum in 1 over 3 into 10 raised to the power 8 of a second. This shows that distance is derived based on time. Next, let us look at current electricity. The base unit of electricity is ampere, which is nothing but the rate of flow of charges. This is related by the equation I is equal to Q by T. One charge is the flow of 6 million electrons. So 1 ampere logically is the flow of 6 million electrons per second. Again, this shows that current and time are directly linked. Believe me now? But really, what is time? Since this channel is based on maths and physics, let's look at how math defines time. In math, time can be defined as an ongoing and continuous sequence of events that occur in succession from past through present and to the future. Time is used to quantify, measure or compare the duration of events or even the intervals between them. Earlier, time in seconds was originally calculated as a fraction of the day, that is 1 over 60 times 60 times 24 of a day. This was taking into account that Earth's revolution was constant. However, this is not the case. So the modern day definition of 1 second is really the frequency of an oscillation which can occur in the nucleus of a cesium atom. The second part of this definition, which says that time is used as a medium of measurement, is fine. The part that I want to focus on is the former. It says that time is a continuous sequence of events that occurs in succession from past through present and to the future. This implies that time is constantly flowing in one direction, independent of any other variable. It's the same thing that we're taught in school. Quantities like time and mass don't change at all. This, however, isn't true. According to Albert Einstein's theory of relativity, time is not constant. There are 2 parts to his theory. The first, of course, is the special theory of relativity. Here, there are 2 postulates. The first part is the assumption that the general laws of physics are applicable universally. The second is that the speed of light is constant regardless of the motion of the light source or the observer. Imagine it like this. A person is standing right in the middle of a platform. There are 2 simultaneous lightning bolts that strike on either side of him. Now, to that person, the resulting light that has been illuminated from the lightning strikes would reach him at the same time. This is because the speed of light is constant. Now, let us take another person. This person is on a train that travels at the speed of light and is passing by the platform. The person inside the train also sees the two lightning bolts, only this time not at the same time. Why? Logically, the light from the lightning bolt closest to the person would reach him first, if the speed of light was a universal constant. The light from the second lightning bolt would only reach the person after the first bolt, which shows that the time is not constant for both people, the one on the train and the one on the platform. Since the speed of light is a constant, there has to be some changes in time to compensate for this discrepancy. Therefore, it can be concluded that time slows down for the person on the train, and this thus gives rise to the special theory of relativity. This phenomenon of time slowing down is known as time dilation. Similarly, the general theory of relativity goes in depth of how space-time can bend as a result of gravity. While I won't go into details of it, since it shifts our focus away from the video, in short it means that gravity can alter time. At the top of a mountain, a person's clock will run fractionally faster than the same person's clock at the bottom of a valley. This isn't only a theory, however. This has been tried and tested using atomic clocks. But let's shift our focus back to yogic sciences. Similar to how in today's day and age, time is very important and is subject to intense calculations, so was the case 15 to 20,000 years ago. In fact, back then, it too was believed that time has multiple types, but through the ages, such science has unfortunately stayed buried. The ancient yogic book, the Surya Siddhanta, also defines in it the definitions of time. It says that time is of two kinds. The first, which is continuous and endless, destroys all animate and inanimate things, which is also the cause of creation and preservation. The second is that which can be known. This latter kind of time is also divided into two kinds. The first is called murta, which means measurable, and the second is amurta, which is immeasurable by reasons of smallness. The time called murta begins with prana, which is a proportion of time containing 4 seconds. The time called amurta begins with Thruti, which is a very small proportion of time, which is 1 over 33,750th part of a second. The time which contains 6 pranas is called a pala, and that which contains 60 palas is called a ghatika. These are the examples of the ancient units used 15 to 20,000 years ago. Mind blowing, right? The variation of time may not be the same as has been defined in today's physics, but the fact that time in itself was thought to have multiple dimensions so many years ago is in itself incredible. Here, let us look at an example of how ancient calculations correlate to today's calculations. We will take the speed of light. In ancient times, the speed of light was calculated by two main units. The first was a yojana. 1 yojana is equivalent to about 9 miles or 14,484.1 meters. The second was a nimisha. 1 nimisha is equivalent to about 16/75th of a second. The speed of light was calculated as 2,202 yojanas in half a nimisha. Using the calculations as you can see on the screen gives us the speed of light as 2.99 into 10 raised to power 8 meters per second. Modern day calculations show that the speed of light is also 2.99 into 10 raised to power 8 meters per second. The only error between the two calculations is 0.26%. 0.26%. Can you believe it? That is almost nothing. And remember, these ancient calculations were done with almost no scientific apparatus. only using keen observations. It just goes to show the power of the human mind and how mathematicians in that time were able to use it to produce such outstanding calculations. That's all for today's video. I hope you enjoyed watching it as much as I did in sharing what I already know. The topic of time is not over. I plan to make it into a series and this was only the first part. The next video, however, will be based on the number 108. Why is it so prominent in cultures all around the world? And how is it used in maths, in science, and the world around us? We'll explore that in the next video. Thank you for tuning in, and until next time.